Welcome back. This is a video in the Mockito series as part of Tales from the Jar Side. My name is Ken Cousin, and I want to show you an interesting little feature of Mockito that I kind of have to confess I didn't know about when I wrote my book, Mockito Made Clear. Now, the book's not supposed to be exhaustive, so that's okay, and this is a somewhat lesser known and lesser used feature, but if you happen to have this particular use case, it can be very, very helpful to know about. Now, why am I doing this? Well, I was browsing Twitter, at least waiting for it to finally give up the ghost and go under, but for a while I'm still keeping track of interesting people on there. And one of those interesting people is this person here. Now, I'm going to try to pronounce his name, and I hope I get it fairly close. Maciej Bakowiak? At any rate, he's from Poland, and he writes extensively and records on YouTube on Spring, and he's got a bunch of testing videos as well. Well, he put up this tweet that said, Mockito tip, use verify mock with a timeout to verify mock interactions that happen asynchronously. And that's what I want to illustrate for you. So let me give you the situation. I'll show you the actual implementation code and then the test, and watch it fail, and then we'll fix it by introducing this timeout. So here is code in my GitHub repository for the Mockito Made Clear book. I have a person service, and inside that person service, I have one attribute that's a person repository. That's the class that interacts with whatever the persistence mechanism. And the only method I care about in the person repository is a save method. I'm going to save a person and return that person again, presumably with a generated primary key or something like that. Now, that means all I really want to do is have my business logic call save on the repository. But let's make this asynchronous. So I've introduced a method in my service called async save people. I'm going to save save person rather. I'm going to save the person, and I'm going to introduce an artificial delay that I can control. We'll talk about that a little bit more later. Now, the way I'm going to put this on a separate thread is I'll use the run async method on completable future, which has been around since Java 8. Now, what run async does is it takes as an argument a runnable. This static method will return a completable future that is asynchronously completed by a task running on the fork join pool common pool. So here is my runnable. See, it takes no arguments, and then I have a block lambda. On the block lambda, I'll print out which thread I'm on, just to verify for my own knowledge that I'm not on the main thread anymore. Then I'll introduce a sleep, just a regular thread sleep for that delay period. And finally, after that sleep is over, but still is part of the completable future, I'll save the person in the repository. So this method delays and then saves. So I'm running on a separate thread. Now, the hard part for testing purposes is the method returns void. It doesn't return anything. And methods that return void are notoriously difficult to test. Usually the way you try to test a method that returns nothing is you look at the state of the object and see if it changed as a result of the method call. But in this case, the only attribute I have is the repository, and that doesn't change as a result of the method call. I suppose I could try to get the person out of the repository, but I'm going to try something different first. What I'm going to do is use Mockito to verify that if I mock the repository, I can verify that the save method was called on that repository with an argument of type person. Now, here is the test. The person service test is annotated with extend with Mockito extension. That's a JUnit 5 extension for Mockito. And that allows me to use these annotations here, @mock and @inject mocks. The @mock annotation will create a mock of this person repository interface. The inject mocks annotation will instantiate the person service and try to plug in the person repository. Now, I provided a one argument constructor specifically for that purpose, so that'll work just fine. Normally after that, you would set expectations on the mock, but again, this method I'm testing isn't returning anything, so there's nothing to expect. So when I write my test for async save person, I get a person from a collection I've created already, and I set a delay, and I call async save person with that person and the delay. That's the method I want to test. Of course, there's nothing to assign it to. It's returning void. So the way I'm going to verify that it got called is to verify on that mock repository that the save method was called exactly once with that person. And this is going to fail. So let me run it and we'll watch it fail. And then we'll go ahead and see what the problem is. So here's the issue. When I look at async save person, it says wanted but not invoked the save method on repository with this person argument. That's the toString method on there. Actually, there were 0 interactions with this mock. So it didn't happen. Now we know the truth is it just didn't happen yet. There was a delay. The test did the verification too soon. So how am I going to fix this? Well, if you look in the Mockito documentation, here are a couple of methods from the Mockito class. These are static methods. Verify that take a mock, and verify that takes a mock and something called a verification mode. Now, the verify that just takes a mock is the one I used. It verifies that certain behavior happened exactly once. Whereas the second argument, verification mode, is usually used to say that something happened at least once, an exact number of times, never. There's all sorts of options for that. And those are the ones I have in the book. Those are the ones I've used. But it turns out that if you look at the verification mode interface, it has a child interface called verification with timeout. And that's what this timeout method is all about in the documentation. This line here says, oh, verify that on this mock, the foo method was called 5 times, but wait 100 milliseconds for those times to happen. Likewise, this one, verify on the mock that the baz method was invoked at least once, but give it 200 milliseconds before you give up on that actually happening. So what this means is if I go back to my test here, all I have to do is put in my second argument of type, or the method called timeout, and I will put in a certain delay along in milliseconds. Well, that's why I made sure I know exactly what the delay is on the original invocation. I'll just wait twice as long just to be sure that it's finished when it's going in the alternative thread. And now when I run the test again, you will see it passes. No problem. And by the way, I am running on the fork join pool, common pool on one of the worker threads. So I am asynchronous, and this worked. And that's all you have to do. Now let's look at the issues with this, because it's not perfect. If I look in the docs for timeout say, verification will be triggered over and over until a given amount of milliseconds passes by, allowing testing of async code. Useful when interactions with a mock object did not happen yet. That's exactly what I have. Extensive use of timeout method can be a code smell. There are often better ways to test concurrent code. In addition to that, if you look at the documentation in the Mockito class, there's a section that says verification with timeout, says basically the same thing, but right here it says, this feature should be used rarely. Figure out a better way of testing your multi-threaded system. Well, in this particular case that I set up, it's pretty much exactly what this use case is designed for. I don't need to use some complex mechanism when all I want to do is say, look, I know this method's going to get called, and in fact, I know how long it's going to be before it gets called, roughly. So just wait longer than that and check. All I'm trying to do is verify that a method that returns void got called by checking that it invoked a method in turn. That's all I'm doing. I'm not really creating some massive concurrent system that I want to work with. Now, if you do create a big parallel system with lots of design for concurrency and everything, what should you do? Well, for example, in the Spring Framework, if you're using the WebFlux module, they use Project Reactor. Project Reactor has a class called Step Verifier that is a client that can subscribe to your publisher, and therefore it will respond to signals as they're sent. That's one way built right in. And all the APIs that implement reactive streams have some way like that. If you don't have that or any of those, there's always the Awaitility API, which is another open source project that handles asynchronous coding. So at any rate, there you have it. It's an easy mechanism that I could use to delay my verification until my code is ready for it. And it worked just like a charm. So I hope you find that helpful. If you have that particular use case, it's easy enough to do. The code is in the GitHub repository for the book. So feel free to like, comment, share, and subscribe, and I'll see you again in the next video. Thanks.